Hey guys, so today we're going to be learning how to evaluate the 6 trigonometric functions when given a coordinate point. So I'm sure you all know the 3 basic trig functions: sine, cosine, and tan. We've all learned these before, but there are 3 others. And the 3 others are just a reciprocal. And a reciprocal is just a math term for opposite. So there is cosecant, secant, and cotangent. So our first example is going to be pretty basic. I'm going to be using 512 as our terminal side. And the terminal side is basically the point on your graph that you're going to use to outline your triangle. So I'm going to go ahead and draw our graph. For some reason I forgot to count, and I obviously could not figure out how to count up to 12. Alright, so you draw your point, and then you're going to connect your point to the middle of the graph. And then just finish drawing your triangle. And I went ahead and labeled my y and x, so 5 and 12, and we don't know the value of that side, so I just put question mark, so we can go back and solve that in a minute. And I went ahead and marked the angle that we're going to be using, so I put it as theta. And then on the side, I'm just going to grab another color pen and do the first 3 trig functions that we know, so sine, cosine, and tangent. And at the top, I'm just going to write SOHCAHTOA, just in case you need a reminder of what each of those 3 means, because I know sometimes it's not something we just use all the time. So we know sine is opposite over hypotenuse. So we have our opposite, but we don't know our hypotenuse. I'm just going to go ahead and label the sides just so it's easier to figure out. So like I was saying, we know sine is opposite over hypotenuse. So we have our opposite, but we don't have our hypotenuse. But don't worry, all we need to do is do the Pythagorean theorem. So I'm going to do 5 squared plus 12 squared equals r squared. I'm just going to go ahead and label that side r just to give it a value. So we know 5 squared is 25 plus 12 squared, which is 144, and that's going to equal 169. And so then we just do the square root because we can't have a squared value. And so then we figure out that the square root of 169 is 13. You can just put that in your calculator. So we know our hypotenuse value is 13. So now we can go back to our 3 trig functions. And so opposite over hypotenuse, that would be 12 over 13. Our cosine would be adjacent over hypotenuse. And then our tangent, which would be opposite over adjacent. And now we're going to go ahead and do our 3 other ones, so the reciprocals of these. So like I said before, the 3 reciprocals of these would be cosecant, which basically when you're doing the reciprocal, you can literally just switch the numbers and you have your answer. So then we would do secant, and we would just switch our cosine values, and then cotangent, and we would just switch our tan values. Now moving on to our second example. So we're going to use the terminal side point at -4, 10. So I'm going to go ahead and draw the graph like I did before. Maybe this time I'll remember how to count. Alright, looks like I'm on a roll. Alright, so I went ahead and just put it at negative 410. I'm drawing my triangle. I'm going to go ahead and label my sides like I did before. And these problems are very repetitive. The only thing that changes are your number values. So we're just going to do what we did before. I'm going to go ahead and write out my first three functions: sine, cosine, and tangent. And again, since we don't have the value for our side, I'm just going to go ahead and do the Pythagorean theorem, because I do need the hypotenuse side in order to solve my trig functions. So I'm going to go ahead and do that, and it's going to just equal to 116, and I'm just going to do the square root of 116, and that would be my r value. So I'm going to go ahead and do my three main trig functions just off the top of my head, knowing what sine, cosine, and tangent is. And then I'm going to go ahead and go over and do my reciprocals. So my cosecant, secant, and cotangent. And again, these are just switching the values of your first three. And that's it for the second problem. So we're going to move on to the third one. Now we're going to do our third and last example. So our terminal side for this one will be at 12, negative 7. And this one isn't much different. They're not really ever that different. The only thing that changes is your terminal side. So I'm going to go ahead and draw our graph. I'm taking my sweet time, obviously. I'm going to figure out where our point goes. Alright, any day now. And I'm going to draw our triangle. That line is definitely not straight, but we're going to move on. Alright, so I'm going to go ahead and label our x and y. So I'm going to put my negative 7 there, and then my 12. Going to label my right angle and my angle we're going to be using, so theta. So I'm going to go ahead and label our hypotenuse side, our adjacent side, and our opposite side. So we don't know our hypotenuse, which is not a problem, because guess what we're going to be using? You guessed it, the Pythagorean theorem. So I'm going to go ahead and do 7 squared plus 12 squared equals r squared. Our r value is the hypotenuse side. And we're going to go ahead and just do that real quick. So 49 plus 144 equals, drum roll please, 193. And then we're going to do the square root of that, and that will equal our r value. Once I figure out what I'm doing, honestly, I was doing things out of order, but it's fine. So the square root of 193 is our r value. Alright, I'm going to change pen colors real quick, try to make this a little bit more colorful. So I'm going to do the first three that we all know: sine, cosine, and tangent. Don't forget to put your theta whenever you're writing it out, just so people know that that is what you're looking for, because if not, you'll probably get it wrong. Just math people need to know what you're doing. And then by now it should become pretty quick as to what you're looking for. So your sine, what your sine means and what your cosine means. Tangent. Then I'm going to switch pen colors yet again. And we're going to do our reciprocals. So cosecant, we would just switch our values. Secant. And then cotangent.